Chi-squared distributions, chapter 11. Here we go. So these distributions are different than the z and the t distribution in that they only take on positive values and the shape is skewed to the right. The formula for the test statistic or calculating that chi-squared value, it's on your formula sheet. It's the sum of the observed minus the expected squared divided by the expected. The reason it only takes on positive values or zero is because we're squaring those differences and summing them up. The way that we tell the difference between the three tests, goodness if it has one variable, one sample, it's a one-way table. That was the M&M question that you did. Chi-square test of homogeneity is one variable, two or more samples, or it could be an experiment. This is when we did the gummy bear question to see if there was a difference in the color distribution for the two brands. And a chi-square test of independence is two variables, but one sample. So is there an association between, say, eye color and hair color? All right. So here's a specific example. The AP people. The College Board claims these are the percent distributions for scores on an AP exam. So here's the results from Fairport last year, a random sample. Full disclosure, just made this up. That's not their actual data. Is this distribution different than claimed? You'll remember for chi-squared, the hypotheses are all in words. There's no parameter that we're using. So the null hypothesis would be that the AP claim distribution is true in Fairport. That's the population we're looking at. And the alternative would be that the claim distribution is not true. So CVS, the random condition, a random sample of 61. How did I get that? Sum this up. 10%, 61 is less than 10% of all Fairport AP Stats students ever. I don't know if that's true. Again, I made up the context a little bit to have some fun. Large counts. We got to check the expected counts to see if they're all at least 5. So I'm just taking the sample size and multiplying it by those percentages that they claimed, and all of these numbers are greater than or equal to 5. Conditions are met. We're going to do a chi-squared goodness of fit test. The degrees of freedom are 4. It's the number of categories, 1, 2, 3, 4, 5, minus 1. The do step, it's going to be the observed minus the expected squared divided by the expected, sum these up. But I can have the calculator do the work. If I plug the observed in list 1, the expected in list 2, and then I go to, let me actually show you. If I go to stat test, goodness of fit test, as long as I have those in there and then put in the degrees of freedom, I don't have anything in my list, so it would give me an error and then hit calculate. What's going to spit out at you is the test statistic, the p-value, and your degrees of freedom, but you had to input them. So I like kind of doing this by hand just to show you. To get the p-value, you use chi-squared CDF from that test statistic to infinity with your 4 degrees of freedom. So in this case, the p-value is really small, so we're going to reject the null. We have convincing evidence that the distribution is not true in Fairport. So why? Why did we reject the null? We need to do this follow-up analysis. So there's a lot more ones than we expected, 20 versus only 6.1. That's going to be what I talk about in the follow-up analysis. Let's look at the other type of, one of the other types of the chi-square test. Is there an association between gender and movie preference? Perform a significance test. So the null would be there is no association. The alternative, there is an association. Random sample of 60, we're just assuming because they're not 60. Why did I say 60? Of 113. And 113 is less than 10% of all people. Large counts condition. This is where you have to do the matrix in the calculator. I'll just show you those couple of buttons. It's second. Let's do this. Make this zoom out a little bit. Second, and then x to the negative first. You're going to go over to edit. Put in the number of rows and columns, not including totals. And then I type in my counts. Then you're going to run your test, but just chi-squared test. And that'll give you your do step. The expected counts are going to be put into matrix B. So if I go back to edit matrix B, those are the expected counts. There they are in the table. Make sure you have a key so your AP reader knows you know which one's which. So the conditions are met. We do chi-square test for, not association, I don't know what I was writing, independence. The chi-squared test statistic, we have 7.03, p-value, and degrees of freedom from the calculator. P-value is less than alpha. We reject. There's convincing evidence of an association. We need a follow-up analysis. So we have less males that like the movie Titanic than expected. That's the main driving force behind why we rejected the no. That's it for chapter 11. We'll see you on chapter 12.